Hi you guys, today we're going to be talking about angle of elevation and depression. We are going to be using our SOHCAHTOA still, so where we have the sine over the opposite over the hypotenuse, so sine equals opposite over hypotenuse. And then we have cosine, which equals adjacent over hypotenuse. And then we have our tangent, which is opposite over adjacent. Alright, so that's just our SOHCAHTOA I wanted to remind you guys of. And we're going to go over our first example here. So a tree casts a shadow that is 21 meters long at a certain time of day. The angle of elevation to the sun from the tip of the shadow is 51 degrees. What is the height of the tree? Remember, you want to draw pictures for all of our examples here. So I'm going to start off by drawing my tree that casts the shadow of 21 meters long. The angle of elevation, meaning elevation, I'm from down below here and I'm looking up. So if you draw a little stick figure, they are down here looking this way and then they look up. So this angle of elevation, that's the angle of elevation right here. Okay, so the angle of elevation to the sun from the tip of the shadow, so this is the tip of the shadow, up to that angle of the actual sun, and we have 51 degrees here. And what is the actual height of the tree? So that's what we're trying to figure out. So we're going to use SOHCAHTOA because we have a 51 degree. We're going to go from this angle. We see that we have an opposite of that angle, and we also see that we have the adjacent side to that. So I look in SOHCAHTOA and I see which out of the trig functions have the O and the A, and I actually see that it is TOA. So I'm going to use tangent. And we always put the angle measure, degree measure after the trig function. Then we set up our ratio. It's opposite over adjacent. I'm going to go ahead and now solve for this by multiplying by 21 on both sides to get that x by itself. And I get 21 tangent of 51. And so when I plug that in my calculator, I end up getting x equals 25.9 meters. So that is the height of the actual tree. For our next example, a person in a lighthouse is 32 meters above sea level. So we are going to be 32 meters in our lighthouse, not just 3 meters, 32 meters. And that's our lighthouse that we're above sea level, and they actually sight a buoy. So now they're actually up here, they're sighting a buoy that's down. So if the angle of depression, so that's this depression now, I know it's a sad word, we are up higher in something, so right now our sight is this way, we're looking up and then we look down at something. So this angle right here is actually the angle of depression. However, if we were to do that, we were looking up like this is our dotted line where this person was standing and looking. Well, now they're looking down. However, this angle is not in the triangle. So we have these angles, if this is my triangle here, we have these angles called alternate interior angles. This was when you guys had the parallel lines with that transversal. So this is our transversal. These angles here are alternate interior angles. So that means that our angle of depression is actually the same angle of our angle of elevation. So we are saying that this angle right here is 20 degrees, which means that our actual angle of depression is 20 degrees, which alternate interior would be this angle inside of our triangle in order to get it in the triangle and actually calculate a value, which is now the angle of elevation, which is pretty cool. So now we want to see how far from the base of the lighthouse the buoy is. So this is where we're going to be having our x. So using our SOHCAHTOA, we see that we have this angle here. The value we have directly across from it is the opposite, and we have our adjacent. We don't have it yet, we're trying to figure it out. So again, I'm going to be using tangent. So I have tangent of 20 degrees. Remember, the angle the degree measure of the angle always comes right after the trig function, 32 over x. Oh, well, our x is in our denominator now, so we actually have to multiply both sides by x. These will divide out, but now we're left with x times the tangent of 20. We do not have x by itself yet equals 32. We need to now, since it was being multiplied, we now need to divide by the tangent of 20 on both sides. So when we get this, we now have x equals 32 divided by tangent of 20. I will again show you guys how to put this in your calculator when I see you in class. But when you do put this in the calculator, you get 87.9, and that is how far the base of the lighthouse is from the actual buoy. So the main key here, this is angle of depression, but alternate interior angles allows you to have the angle of elevation and gets your angle inside that triangle. We're going to go ahead and practice one more. So at a certain time, a post is 6 feet tall, cast a shadow. So again, I'm drawing my pictures. Cast that shadow of 4 feet again. And then we want to see what is the angle of elevation of the sun. So we're trying to see what that angle is. I'm going to just make this triangle a little bit smaller so I have something to write with. So now we're trying to figure out what that angle of elevation is. So now our x is actually inside. This is where we will use our inverse trig functions. So again, we want to see what side we have. We have the opposite over our adjacent. Again, I'm using tangent. However, this time I don't have a number to put in for my degree. I have to put that x in. So now I have opposite over adjacent. And now this is where, since I'm trying to find a degree measure, this is where we use our inverse trig functions, and we put this in our calculator as tangent inverse of 6 divided by 4, and we get x equaling 56.3. And remember, it is a degree because we just found an angle measure, so make sure you are putting that degree sign for your angle. So the actual angle of elevation to the sun from that shadow is 56.3 degrees. All right, you guys, that's it for today. We will go over this in class, and have a good day.